Hey guys, so today we're going to be dealing with our trigonometry and how do we find in terms of certain angles. All right, so what they've given us here is they say in the diagram below we have that DCB is alpha and that AC is H amount of units. Okay. They also give us that ACB is our theta. Now it says determine the size of ACD in terms of alpha and theta. Now this is important because it means that your answer needs to include alpha and theta. So if we look, they're asking us for ACD. So they're asking us for this angle. So they want to know what is the size of this unknown angle. Now, if the entire angle is theta and that portion is alpha, would you not assume that that middle portion would be theta less alpha? Because that would give us our difference. Okay, so that would be the size of ACD. Now, since we have the size of that angle, what I like to do is just go add it back in on my diagram so I know what is what. Because if you don't put it back on your diagram and you have to go read through all of the answers you've gotten, it wastes time. Okay, now if we look at the next one, prove that AD is H sine theta minus alpha cos of A. Now, what you need to take into consideration here is, are we going to have to use our sine rule? Are we going to have to use our cos rule? And usually when it's in a fraction form, although this one has cos, it's actually a sine rule. And don't forget that your sine rule would be in the form of A sine of the angle, B over sine B, and C over sine C. Okay, now what's important, and let's just make that a lowercase b so that you can distinguish the difference. But what is important is knowing what triangle you're working from. So they want AD. So they are looking over here. What that then says to us is I need to find what is common between the triangles. So what I can do, if I look, it's got a sine theta minus alpha. So this is sine theta minus alpha with its opposite side. So I already know a portion of my formula is going to say AD equals sine theta minus alpha. But now the other side is the concerning part. So we would have H over. Now the reason I chose H is because there's H within our proof. So H, if we're doing the sine rule, do you see that angle D1? So this is now what you need to try and prove. But do we know the size of angle D1? Well, right now, no, but you can solve for it. So angle D1, do you see that it is the exterior angle of this triangle? Meaning that it is equal to the opposite two interior angles. So D1 is 90 degrees plus alpha, exterior angle of a triangle. And now I have my angle D. So now we're going to say that AD over sine theta minus alpha is the same as H over sine. Now I have my D1 value, so now I just sub it in, 90 plus alpha. Now you're going to see where we came up with our cos alpha, because this here is a cofunction, which will change to our cos alpha. All right, now we need to quickly go and fill in the rest. We have AD over sine theta minus alpha equals H over cos A. And now they asked us for AD. So that means we need to multiply the other side by that sine theta minus alpha. And now we have what was required. Okay, we've just proven it. If we go look, they asked us AD must be H sine theta minus alpha over cos alpha. All right, so hopefully that has clarified this question. We need to move on to question 3. All right, for question 3, they now say we need to determine the actual length. Before, we only proved what the length was in terms of. So now we need to actually fill it in. So we need to determine determine AD if H is 17 units, theta is 58, and alpha is 23. All that means is you use the formula from above, that H multiplied by sine theta minus alpha over cos of alpha. Okay, now I'm just quickly going to fill in the other angles on this diagram as well. This was our theta minus alpha. We determined that that was 90 degrees plus our alpha, just so we have all of our measurements. Now we're just going to plug and play our information in. We have 17 sine our 58 degrees. Don't forget your degree symbol. 23 degrees all over cos of alpha, which is 23 degrees. If you put that into your calculator, you should then come with the value of 10,59. And because it's a length, we say units. And once I have that measurement, I always add it back onto my diagram. Now the last question. We need to calculate the area of triangle ADC. So triangle ADC. This is not a right-angled triangle. And because of that, we have to use our area rule, being a half BC sine A. But there is another way to do this question without that. But because I'm testing this principle, in today's example, we will just be using the area rule. So what that means is we have to identify sides and an inclusive angle. So if I try to use this measurement, all right, I've got my side and inclusive angle, but I don't have DC. And it's going to be quite difficult to calculate DC. If I tried this measurement as well, all right, that being the inclusive angle, we have our side length and then this side length, it's still DC, which makes it difficult. But if I place it this way, and I always teach my students that they look like scissors. So your inclusive angle is the angle that you would be cutting with your scissors. All right, so that would be angle A. Do you see that we have our two side lengths? And it's quite simple to calculate the size of A because we're just going to do angles in a triangle. And if you use their actual values that we got from above here, you would now determine that this one would have been 90 degrees plus alpha, which alpha is 23 degrees, which gives us an angle size of 113 degrees. Here we would determine that our angle size would have been our 58 degrees minus 23, and that gives us 35 degrees. And then we can just do sum of angles in a triangle. So to get CAD, we would just say 180 minus that 113 minus that 35 because of sum of angles in a triangle, which would then mean that our angle A must therefore be 32 degrees. Now do you see I've got my outer arms and I've got the inclusive angle, which means I can now get the area of triangle ADC, being half of those legs being h and our 10.59. I will sub in h now, it's just to help simplify it. And then sine of our angle A. We know what our h is 17 units because you can see that in the previous question. And we calculated 10.59 as well from the previous one. And A we just determined to be 32 degrees. If you put all of that into your calculator, you should get 47,70. And now remember, because it's area, you need to tell me units squared. Okay, it's very important that you square your units. All right. Okay, so hopefully this was helpful in explaining this example. You just need to ensure that you don't forget the scissor analogy, all right? That you are cutting, all right, the inclusive angle, and then that the arms of your scissors, those are your sides that you would use in your form.